Welcome back. We're going to be working on the start of chapter 8. This is chapter 8, section 1, geometric mean. Now, geometric mean is ways that we can solve problems that have relationships in right triangles, but parts of them. And we're going to be doing that with this geometric mean thing. Let's talk about what that is. The geometric mean is when the means of a proportion are the same number. So if we think back to our proportions, when we had the extremes and we had the means, when these are the same value, then the geometric mean is that number is called the geometric mean of the extremes. And so it's going to be the square root of the product of these two numbers that are different. And so we end up with, get my marker going here, we end up with this little formula for us to use. Now let's go ahead and practice that real quick. So here I've got some numbers. Find the geometric mean between 8 and 10. So using the definition of what it means to be a geometric mean, we write our formula. And our formula is x equals the square root of a and b. Now, a and b are just representing the two numbers that I'm starting with, a and b. So we write them under the square root, multiplied them together. And now we're going to simplify this square root. And I'm going to do that work over here so you can see what we're doing. So we have x equals the square root of 8 times 10. But I'm going to think of 8, not as 8, but as all of its prime factors. So I'm going to list all the prime factors of 8. That is, I can get to 8 by thinking 2 times 4. And then I can think of 4 as 2 times 2. And so this list of numbers here are my prime factors of 8. So hang on, let me just erase this real quick, give myself some more room. I'm going to think of that 8 as 2 times 2 times 2. Okay, there's 8, 2 times 2 times 2. And then I'm going to look at 10 and I'm going to try to find the prime factors of 10. Well, I can get to 10 by multiplying 2 and 5. Nothing else to do with the 2, nothing else to do with the 5. So those must be the factors of 10, the prime factors, 2 and 5. And so now to simplify this square root, what I'm going to be thinking is I'm going to be looking for pairs, because that's what square root is really asking for. Excuse me. Square root is really asking for how many factors inside of me do I have 2 of? Well, I have 2 2's right here. So that's going to come out. I'm going to list that factor. And then I have 2 more 2's right here. So I'm going to list that also. But so that this doesn't look like I just wrote 22, these were separated by a multiplication inside. So I'm going to separate them by a multiplication when I write them outside. Now I don't have any other pairs in there, and so I'm going to write my square root, and I'm going to write whatever is left over inside of the radical after I list all the things that I have a pair of. So the 5 remains inside. Going to do a little bit of cleanup by multiplying those 2's together, and I find that x is 4 square roots of 5. And if I stick that into my calculator, I see that that's about 8.9. Let's go ahead and do a few more. I've got some guided practices here. So I want to find the geometric mean between these pairs of numbers. I've already given you the answers, so let's figure out how they did that. I'm going to start off first with the formula for geometric mean, and let me zoom in a little closer on my workspace so we can see what I'm writing. All right, so my formula for geometric mean is x, the geometric mean, is the square root of my first number, which we called A in the formula, times the second number, which we called B in the formula. In this case, my second number is 45. All right. I'm going to rethink of these numbers as a list of all of their prime factors. So I'm going to think of 5 first. What do I multiply together to give me 5? 1 and 5. 1 doesn't really help me when I'm dealing with factors, so I'm going to leave that 5 all by himself. I'm not going to do anything. So I've taken care of this one. Now I'm going to think about 45, and I'm going to find all of the factors of 45. So I can get to 45 by multiplying 5 and 9. And if you're not sure how to get these, you can grab a calculator and you can take 45 and just start guessing some numbers and divide 45 by whatever your guess was. If you get a decimal, then it's not a factor, and so you try a different number. If you get a whole number, then those two numbers that you put in, the one you divided by and this answer, those are factors. All right, so continuing to think 5, I already realized that I couldn't do anything more, so he's going to stay by himself. But I can think of the things that multiply together to give me 9, the factors of 9. That's 3 times 3. Can't do anything with the 3's, those are primes, so this list is my prime factors of 45. And so I'm going to write those next. Now, just a reminder, the way I write my square roots is that I don't put the roof on my square root until I'm all done. And then I close the little door with a little chick on the end. And that's just so that I know that my square root is done and I don't run the risk of anything falling out of my square root. Okay, now I'm going to look into my square root and I'm going to see everything that has a pair. So everything that I have 2 of. I have 2 5s, so I'm going to write a 5. I found a pair of 5s, and then I'm going to do multiply. And then I'm going to look and see if I have any other pairs. Yep, I have a pair of 3s, so I'm going to write here a pair of 3s. I don't have anything left over in the square root that wasn't circled. Everything had a buddy and a pair, and so I'm just going to multiply 5 times 3 together to give me 15, which was the answer that I was given at the very beginning. So I know I did this one properly. One more example. Let's look at 1B. All right. Directions stay the same. We want to find the geometric mean, and we're going to do that of these two numbers, 12 and 15. And it looks like my answer is going to have a square root left over. All right, I'm going to start with my formula. Let me zoom this back in to make it nice and easy to see what I'm writing. All right, square root of the two numbers I was given. I was given a 12 and I was given a 15, and I'm multiplying those two together. I'm going to think of 12 as a list of its prime factors. So I'm thinking about 12, and I can get to 12 by multiplying 3 and 4. And I can get to 4 by multiplying 2 and 2. So here's my list of prime factors for 12, and I'm going to write those right in here under my square roots. And then I'm going to put the multiply that I see here between the 12 and the 15. And I'm going to go and I'm going to find the prime factors of 15. 15 is 3 and 5. And I can't go any further because those are both primes. So I'm going to write the 3 times 5 inside the square root. All right, now I'm going to do what square root is asking for. Square root is always asking for a list of factors inside of the square root that I have pairs of. All right, I have a pair of 3s. Sorry. Okay, I have a pair of threes, so I'm going to write a 3 down because I have one pair of threes. And then I'm going to put a multiply, and I'm going to keep looking. I have a pair of 2s. There's a pair of 2s. So I'm going to write 2 out. Again, I'm just listing which factors I have a pair of. I'm not writing both, like both parts of the pair. I'm just writing I have a pair of 3s. I have a pair of 2s. I don't have anything else that has a pair. The 5 is all by himself, so I'm going to write square root of 5 because the 5 is left over with no partner. Very sad for 5. And I'm going to multiply the 3 and the 2 together. 3 times 2 is 6. And so my answer is read as 6 square roots of 5, which means 6 times the square root of 5. Okay. Now that we've seen how to calculate the geometric mean, the big question is, well, what is it good for? It's good for a couple theorems are about to come up. Let's start with our first theorem, Theorem 8.1, that says if we have an altitude drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Okay, first big vocabulary word is this word hypotenuse. Hypotenuse is always the side that is directly across from the right angle. So if I look at this big triangle, triangle ABC, here is the right angle for triangle ABC. Notice how, let me zoom in real close on that figure. Notice how that right angle marker kind of goes from this side to this other side. So it doesn't stop at the altitude that's been drawn right here. So here I have the right angle of my big triangle ABC, which means this particular side is the hypotenuse. Okay, so what we're going to think about is I'm going to think about this big triangle right here. And let me draw a very messy version of that big triangle. The messiest version I could. There's C with its right angle. There's B. And then here's A sitting over here. Notice how I didn't draw that altitude. This is my original triangle. Here's the altitude from C to D, some point along this hypotenuse, creates a right angle. What this theorem is saying is that this triangle here on the left, which we've got colored in red, this triangle here, this one here, is similar to the triangle on the right side of the altitude, which we've colored in blue. So these two triangles are similar to each other, but they're also similar to the original triangle that I started with in the first place. Okay, let's figure out how we write that. And so in order to help us identify those three similar triangles, the easiest thing for me to do is to draw out the three triangles that I see. All right, I'm going to look right here. I have this itty bitty little triangle on the left side of the altitude. And so we're going to write it right here. So there's triangle FJG. Excuse me. And then we're going to draw this triangle here on the right, which we've drawn in red. Let me go ahead and trace this over in red just to make it a little easier to see. Here's triangle GJH. Now notice that we've kind of spun this triangle around a little bit, so that way the right angle is kind of in the same corner as the right angle of the first triangle that I drew. And then this one is the big triangle, FGH. And again, I've put that right angle so that they're all kind of in the same position. Now it's really easy for me to see which triangle is which and what parts of these triangles correspond to which other part of the other triangle. This is super important for writing that similarity statement. We know that by this theorem 8.1, all three of these triangles are going to be similar to each other. Because they're similar, I can write my similarity statement. The trick to this is to match up the short sides after you match up the right angle. So I've matched up the right angle. These two have the same right angle J. This one's right angle is G. The short side here is FJ. The short side here is GJ. And the short side here is FG. So when I write the name of my very first triangle in my statement, doesn't matter what order you write those letters in. But when you go to write the second triangle's name, you have to make sure that you put them in corresponding order. Since J is the right angle, J needs to go in the same location in the name. Since we wrote it second in the first triangle's name, we're going to write it second in the second triangle's name. F is the point that helps us create the short side. And on this triangle, G is the letter that helps us create the short side of that right triangle. And since in the first triangle's name, I wrote the letter F first, in the second triangle's name, I need to write that letter G first. And then the third letter in my triangle can go last. The same idea happens when I go to write the next triangle in the series. Remember, this is transitive property, and this it's given to us from this theorem 8.1, that these two triangles that got created are similar, and both of these are also similar to the big triangle that they came from. So this is the big triangle that they came from. Now, looking at it here, I can see that the right angle is given by G. In the first two triangle names, the right angle was J, and it was written second in the name. So for this triangle, I'm going to write the name of the right angle in the second position of that triangle's name. Then I'm going to find which corner gives me the short side. In this triangle, the corner named F gives me the short side of my triangle. And since that letter on the other two was written first, in this triangle, that letter is also written first. That's how these were done, these guided practices. I'll give you a moment to read those. And when you go into your skill practice, that's how you'll write your similarity statements. Now, this is all well and good. And this, what is this useful for? Well, when we combine this theorem 8.1 that allows me to see which parts are going to be similar to which other parts, this is going to kind of give to us some formulas that we can use to help us calculate missing side lengths. It's all based on proportions and the geometric mean. Let's take a look at the two geometric mean formulas. We'll read them and then we'll do some examples that talk about them. All right, now that you've had a chance to read them, let me read them to you and talk about the formulas that get created. So theorem 8.2 says that if I can see the altitude that's drawn toward the hypotenuse of a right triangle is going to separate that hypotenuse into two different segments. Segment on one side and the segment on the other. The length of this altitude is the geometric mean between the lengths of these two segments. Here is the formula we're going to use. Notice it's using that geometric mean formula setup, that the geometric mean is the square root of those two values multiplied together. The second theorem is when we are given some leg information and we don't really need to use the altitude. This says that the altitude drawn to the hypotenuse of a right triangle is going to separate the hypotenuse into two segments, just like the first theorem did. But this time, it's the length of the leg that is the geometric mean between the length of the hypotenuse and the length of the segment that is closest to the leg that we were using. Let me zoom in a little bit to kind of get you to see that. So here's my right triangle, and here's my hypotenuse. Let me highlight that hypotenuse in red for you. So there's your hypotenuse, this length from A to B. What this theorem is saying is that this altitude that we've drawn here is going to cut this hypotenuse into pieces, and that it's this leg that is the geometric mean between this part of the hypotenuse and the entire length of the hypotenuse. Let's practice both of these in example number 3. In example number 3, I have this figure. It's got a triangle. It's a right triangle, which means this is my hypotenuse right here from K to J. And I know that I have an altitude from L to M because there's the right angle indicating altitude. We've been asked to find the measure of X, Y, and Z. Let's look at X first. I'm going to zoom in close on my picture. Well, X looks like it's the altitude of this particular right triangle. And so I'm going to use theorem 8.1, the geometric mean with the altitude. And what that said is that this altitude is the geometric mean between this piece of the hypotenuse and this piece of the hypotenuse. Okay, I'm going to write that formula over here. All right, so it said that the height, which in this case is represented by the letter X. Apologies, let me try to make my pen a little thinner, make it easier for us to read. There we go. The height, just had an idea. The height of the altitude is equal to the geometric mean of, that is the square root of the two things multiplied together. The two things being multiplied are those pieces of the hypotenuse that are created when the altitude runs into the hypotenuse. So here's the altitude X. Here is one piece of the hypotenuse. Here is the other piece of the hypotenuse. Now I'm going to simplify this in order to solve for X. I'm going to think about the factors of 5. That's 1 and 5. Those are both prime, so there's no real way for me to help with that. So I'm just going to write 5. And now I'm going to think about the factors of 20. The factors of 20 are 4 and 5. Nothing more for me to do with the 5, but 4 I can rewrite as 2 times 2. So here are my prime factors of 20. So 2 times 2 times 5. Again, thinking about what square roots ask for. Square roots ask for list out the things that inside of me I have a pair of. So taking a look at what's inside of the square root, I see that I have a pair of 5s. So I'm going to write 5 on the outside. And that's going to get multiplied to whatever I can find a pair of next. Ooh, I have a pair of 2s. So 2 is what I'm going to write outside. Again, I'm not writing both of the 2s multiplied together. I'm writing the fact that I have a single pair of 2s and a single pair of 5s. 5 times 2 is 10, and so X, or the height of the altitude of this triangle, is 10. I'm 1/3 of the way there. The next thing I need to find is Y. And so I'm going to rewrite my figure real quick so that I can see it a little more easily. I'm going to use my handwritten notes here so that I can draw it for you as beautifully as I can with a computer mouse. Okay, there's my triangle. K is up here. That is the weirdest looking K I've ever drawn. Let me try it again. Sorry about that. There is K. Here is L. J is sitting down here. Y is here. There's a right angle at L. I have my altitude, which connects at M. Now, I was told that this piece is 5 units and this piece is 20. I've already calculated the altitude, so I could write that in. And now I need to find Y. So I'm going to highlight Y real quick. Wow, my screen went black for a second. Hello, computer, are you okay? Okay, good. I'm glad he's okay. All right, so there is Y. Now, if I notice, Y is not the altitude. Y is sitting on the leg of my right triangle, which means that this is the geometric mean between this part of the hypotenuse that's closest to the leg and the entire length of the hypotenuse. Okay. So once again, the measure of the leg is the geometric mean of, that's the square root with inside things being multiplied. It's the geometric mean between the piece of the hypotenuse closest to the leg that we were given information on or that we're interested in, times the entire length of the hypotenuse that we've been given. All right, there's the measure of the leg, which is Y. I don't know what that is. It's just the letter Y for now. There's the piece of the hypotenuse closest to the leg I was interested in. And now I need the measure of the entire hypotenuse. That entire hypotenuse is 5 plus 20. It's both of those pieces added together. All right, now I'm going to start to simplify and solve this down. So the first thing I'm going to do is I'm going to handle that addition that's inside the parentheses. 5 plus 20 is 25. And now I'm going to think about each of these as a list of their prime factors. 5 is already prime, and so there isn't anything for me to do there. 25 is 5 times 5, and both of those are prime, so I don't need to do anything more than just write those down. There we go. And let's give you a bit more color so you can track what I did. There's the measure of the hypotenuse. And there is that 25 written as 5 times 5. And then this was the piece of the hypotenuse closest to the leg. All right, now I'm going to simplify the radical. And remember that the radical is always asking, what factors inside of me do I have a pair of? And as I'm looking at this, I notice I have a pair of 5 sitting right here. So I'm going to go ahead and write 5 on the outside just to say I have a single pair of 5s. And then left over inside is this 5 right here. So I'm going to write square root, and then I'm going to write this 5 inside the square root because that's what was left over after these two got together and went out on a date. There's my value for Y. Z is going to be calculated the same way because if I look at it right here, Z was written down on this side, which means now I have this leg. And so I'm going to be using the geometric mean of this piece of the hypotenuse closest to the leg and the entire length of the hypotenuse. It runs exactly the way we did for Y. That was it for geometric mean section 8.1. Make sure that you fill out your lesson summary. The steps to simplify radical expressions are, first off, list everything inside the radical as factors, a list of factors. And then since you're grabbing a square root, you are going to try to find all the factors that have a pair. So 2 of the same factors, that's what comes out of the radical. That's all I had. Thank you so much for joining me today. Please don't forget to hit the like button, subscribe, hit the bell, all that good stuff, and we'll see you on the next lesson.